Welcome to 7.7, the determinant of a square matrix, part 2. This is going to be pretty quick and I believe pretty simple, although there's a little trick to 54 and 62. But first off, we're just to find a determinant, and again, this is part 2. We talked about finding these by hand in part 1, but as they get bigger, and truthfully, even anything above a 2x2 with today's technology is probably going to be handled with calculator. So we're going to use calculator just to find our determinant. So let's take a look. If I go into matrix, we've gone in here before. I've taken the liberty of already creating matrix A here, and I will say the bigger they get, the more you want to double check your entries. It's just so easy to transpose a number or to miss a negative or something like that. So when we quit out of here to find a determinant, we go into second matrix. Again, that's right here, x to -1. Second matrix, we're looking for a mathematical process, and determinant's the first choice. And now back to matrix, and we just select the matrix we want the determinant of. And it is that easy. Nothing to it, but once again, it's a problem where if you have that on a quiz or a test, and you may use your calculator, you run the risk if you know everybody's going to know how to do it. Really, the only way you're going to not get this correct would be to have totally ignored the lesson, never done the homework, or to make an entry error. So I'm going to really highly recommend we double check those entries on this. Okay, now the calculator will not directly benefit us in these next problems because we have variables inside the matrix of the determinant we're looking for. So now we have to go back to the downward diagonal minus the upward diagonal. So our downward diagonal product, x times 9x, is 9x squared, minus our upward diagonal is 8 equals 8. So 9x squared equals 16, or x squared is 16 on 9. And it seems like anytime we're doing something the least bit new, even though we've been really good at picking up on some of our algebra this year, anytime we do something new, our algebra brains kind of shut down to the new stuff. But every time we solved one of these during the course of the year, I would have said, how do we get rid of a squared? Careful. And you would have said plus or minus. So this is plus or minus the square root of 16 on 9, or plus or minus 4/3. Okay, 162, or excuse me, number 62. Likewise, we've got to go ahead through our downward diagonal process. So I'm going to rewrite this as 1x -2, 1, 3, 3. Calculator's not directly beneficial here. Rewrite the first and second columns. That's a 0. X, 3, 2. See how easy that is to make a little slip up. Now we want the product of our downward diagonal. So I'm going to find this downward diagonal right here. 1 times 3 times -2, -6, plus the next one. And here's where people make some mistakes. X times 3 times 0. I'll see 3x a lot, but if there's a 0 in there, in that downward diagonal, it's 0. Plus this final downward diagonal, -2 times 1 times -2, -4. So we get -10 on that downward diagonal. Upward diagonal, the first one is 0. This 0, 3, -2, 2 times 3 times 1. The next one is 6, and the last one up here is -2 times 1 times x, -2x, and we add all those together, and we get 6 minus 2x. And we take the bottom, -10, minus the top. Here's a common mistake. Hopefully you all recognize it right away. It's minus the top. And that is the determinant of this, which in turn is equal to 0. So let's see. We get -10 minus 6 plus 2x when we distribute equals 0. Or we get 2x equals, that's -16, 16x is 8. And that is it for this short little video. I wasn't able to complete the last one, but there's our assignment. Should be pretty straightforward, but there's just a lot of little places you could make computational errors. So make certain to ask any questions if you have them, and good luck.